lecture we are going to discuss why the value of cos of negative of theta equals to cos of theta. Okay, so to prove this result, what we need to do, we need to understand the definition of cosine, definition of cos theta. Okay, so to understand the definition of cos of theta, I'm going to consider a circle. Okay, so first of all, I'm taking the coordinate axis x, the horizontal, and the y, the vertical axis. Now a circle with center at O, this one 0 comma 0. Okay, now to consider this angle theta, I am taking upon the angle theta with the x-axis here, this one the x-axis, and angle moving in anti-clockwise direction, that is positive. This is going to be theta. Okay, and this point on the circle is going to be, let's say, P A comma B. A will be its x component and B will be its y component. So to find the values of A and B, I am dropping a perpendicular from here, point P, onto the x-axis here, this one. Now you get the values of A, and this one is for B. This is the horizontal component A and this is the vertical component B. Okay, now moving to the definition of cos of theta. What is the definition of cos of theta? That is equals to adjacent dividing by the hypotenuse. So here in this figure, in this circle, the value of adjacent is this radius O from to P. I am taking it as R. This is the radius. Okay, and sorry, the adjacent. 1 minute. The adjacent is going to be this horizontal distance from this point O to, let's say, this one C, where the perpendicular drops. Okay, I'm taking this one as C. Okay, so adjacent is here, the value of adjacent is A, and the value of hypotenuse is radius of the circle, which is R. Okay, so from here we are going to get the result, which is cos theta equals to A dividing by R. Okay, now consider another aspect, that is what will be cos negative of theta. So for cos negative of theta, we have the standard set for measuring the angle, that if we move in anti-clockwise direction, we take the angle as positive. Okay, so if we move in clockwise direction, then the angle is going to be negative. In this way, you can see this here in this triangle. Okay, in this right triangle, so the angle from x-axis in the clockwise direction, now this is going to be negative of theta. Okay, and now I'm calling this one as point P prime. Here the coordinates of P were A comma B. For the point P prime are going to be A comma negative of B. So now applying the same definition of cos theta on this right triangle O, C, and P prime. So cos negative of theta, this is equals to, again, the value of adjacent. The value of adjacent remains same, that is A dividing by the value of hypotenuse, which is again the radius of the circle O to P prime, that is R. So from here you are going to get the result of cos negative of theta, which is equals to A by R. Cos of theta was already A by R, and now we have proved that cos negative of theta is equals to A by R. They both are same. So what we can say that cos negative of theta is equals to cos of theta. So again, by using the same concept, what we can say, we can derive the results for sine, for tangent, for secant, for cosecant, for cot, so for all the trigonometric functions. So I'm using this concept for sine of theta. So in for sine of theta, what is going to be its definition? The definition of sine theta is perpendicular dividing by perpendicular or opposite also. Okay, perpendicular or opposite dividing by hypotenuse. Okay, so in case of theta, in this triangle O, C, and P, the value of perpendicular is B, whereas the value of hypotenuse is R. So we get sine theta, which is equals to B dividing by R. So this is the answer for sine theta. We can say that B by R is sine theta. Okay, so in case of sine negative of theta, what we have to do, we need to consider the triangle in the at the lower side, that is OC and P prime. For that triangle, the perpendicular is going to be negative of B, because now it is on the negative side of the y-axis. So this is equals to minus B by R. What we can do here, we can separate this negative and this, taking this B by R, and from here you can see that the value of B by R was sine theta. So if I use that value of B by R in this equation, I'm going to get that is sine negative of theta. This is equals to negative sine theta. Okay, so same the method that you can apply for the tangent theta and secant, cosecant, and cot. One more thing that you need to keep in your mind is that the reciprocal of the cos is secant. So the if cos negative of theta is cos theta, so remember the value for the result for secant also remains same. That is secant negative of theta is equals to secant theta. You can also prove this result by the definition of secant theta. Same, the reciprocal of sine is cosecant. So cosecant negative of theta, remember cosecant negative of theta is equals to minus cosecant theta. And one more thing, the functions which absorb these negative signs are known as even functions. Okay, so this is going to be an even function. Cos is an even function, but sine does not absorb the negative sign. It means this is an odd function. Tangent does not absorb the negative sign, so tangent is an odd function. So that's all for today's lecture. Thank you.